Hello guys, let's solve today's GFG POTD. Check for BST. Given the root of a binary, check whether it is BST or not. Note we are considering that BSTs cannot contain duplicate nodes. BST is defined as follows. Left subtree of node contains only nodes with keys less than nodes key. Right subtree of the node contains only nodes with keys greater than nodes key. Both left and right subtrees must also be binary search trees. So let's do it, guys. First, what's the meaning of binary search tree is this node left means if this is a binary search tree, if and only if left subtree is BST, right subtree is BST, and this value is less than 2, and this value should be, right value should be greater than 2, and left value should be less than uh, 2. So that's it. That's the condition of BST. So now let's understand, guys. What he is telling is we have to check whether the tree is BST or not. So for this we'll use recursion, obvious recursion. So if you don't know recursion, you should check anything. You should check on online about recursion, and you should learn recursion properly. Uh, Trees concept recursion is basic thing. You should learn recursion perfectly for doing trees. So let's do it, guys. Let me write a function BST. Now what does this function do? It checks if it's BST or not. Okay, and I will give root. Root means anything. This root if I give, it should tell me if it's BST or not. And what I will give is I'll give two values x and y. I'll tell you what are these x and y values. Okay, so first base case I'll tell you what are these x and y. I'll tell you, okay, if root equal to null, if nothing is there, if root equal to null, you should return true, right? Okay, obviously we'll return true because if here null is there, so it's obviously BST, right? Okay, next what I will do is I will check if 2 is greater than x and 2 is less than y. Okay, 2 means this node value, or we can say root. Okay, or we can say root. Okay, means why we are checking this condition is we are checking till here, means we will not go down here. Okay, we will not go down. We are checking till here if it's a BST or not, means is this the basic condition satisfying or not. We are checking that one. Okay, we will not go down after this condition satisfied. If this condition is satisfied, till now it's a BST, right? No problem in BST. We'll check now left and right nodes, means at the basic first BST condition is satisfied. Okay, first basic condition is satisfied. Now we will check if both right and left nodes are satisfying the left and this tree and this tree satisfying the condition or not. Okay, so now what we will do is we'll check if BST root of left, if it goes left, comma x right. What is the x value here? Now let's think. Okay, see, if we are going to BST root of left, so this is the root node, right? So it calls this function, which function? Root of left, comma x, comma y. I'll tell you what x and y are, but we should put values here. They are not x, y. Means for 2 and 1 both, means x value should not be same, right? They will be different. So there will be some value here and here. Okay. Now understand this one. We are going to root of left. This function I call. So we'll come here. But from here, we should check condition, right? So we'll check. The base condition is same for every function. So if root equal to null, return true. So this satisfies. But root is greater than x, right? This condition should satisfy. Means this condition we are checking, right? If it's a BST of means left tree, if BST or not, we should check this condition, right? So what is this condition? Root is greater than x and root is less than y. So here x is root is greater than x. So here 1 should be greater than x. But 1 should be what? 1 should be greater than x and 1 should be less than y, right? So 1 should be obviously less than 2, right? Obviously, because 2 is greater than 1. So here root is less than y. So we will fill y in the place of root of beta, right? Yeah. And x will remain same. X will be constant. Okay. What we done here is here 1 is there. Okay. So here 1 is there, root of left x comma root of data, right? So obviously 1 should be less than 2 because 1 is left of 2, right? So we are checking if this is satisfying this condition, means it is less than 2 or not, we are checking. Okay, now 3, we'll come to 3, root of right. Okay, so this now here, now 3 should be greater than 2, right? Obviously, right? So now x value, what it will be? X value root of beta will be, right? See, what I am doing is root of data should be greater than x. So here 3 should be greater than 2, right? So root of data comma y, same thing. What we are checking is root is greater than x and root is less than y. So we are checking if this is means this is greater than x. This is the condition. Okay. After this, we will check and we'll put end here. This should satisfy. This should satisfy. Both left and right will be possible, right? And last, if this case possible, else it's false, right? Yeah. So that's the code. That's the logic. First we'll check this is possible or not. Next we'll go to left and right. We'll check upper ones. From here we'll check upper ones. Till here we'll not check. We'll check this upper ones, but these upper ones are not there, right? So int min and int max will be uh, this one. Okay. See, what I am telling is initial in base case here we are checking this is one node. Suppose single node here 2 is there. Now what is left? What is left? Right. Int min and int max, right? Obviously, if there is a node is there, then it should be BST. So int min and int max. So till here it's a BST here, not you're checking here if root of x greater than x and like that. Okay. Then we'll move to left side and check this condition. Means till here it's possible or not BST. Till here it's possible or not BST. So that's the logic, guys. Let's go into it. It's a code. Okay. So first I'll create a function here, BST. Okay, let me write bool BST root and yeah, write int x int y. I'll tell you what are these x y. They are left and right values. Okay, now first base case is common. Return true, right? Now if let me create a number here. What is this number? Is root of data. No need to write. I'll write n. Why bigger things? Okay. Now I'll check if till here it's possible or not. If n is less than x and n is greater than x and n is less than y, it's possible, right? So till here it's possible. Now let's check both left and right. L means left. And x value and y value. Now what we should put x value and y value here? X is common. Here I'll write root of data, right? Root of data means n. Yeah. So why I am writing this, I told you, right? Here root of left x and root of beta. Why we are putting this means should check this is possible or not, right? Means root should be greater than x, but we are doing left here, so 1 should be less than 2. So in the place of x and y I am putting this. Okay, so x and y, x, yeah, and same bool of right BST root of right, here n and here x, or here y comes here. Yeah, because right should be greater than, right? So right obviously, yeah, so root of data and y. Yeah. So here I'll return web development, sorry, return n and r, else return false. Yeah, that's it. I hope it works fine. BST root int max and int min, right? X should be list. Okay, int min. Okay, sorry, int max. Yeah, compiling mistake here. Return. Yeah, it's working fine. Now let's check. Yeah, so that's it for today, guys. We'll meet again tomorrow. Okay, so that's it. Bye.